All right, guys, we'll go ahead and get to it. So this is lesson 1-4. This will be our second to last lesson that we cover in this chapter. Like I told you guys, it'd be short and sweet. So this is lesson 2 of 3, and then we'll have a quiz. Let's say either Wednesday or Thursday. Okay, over this material. Remember that quizzes in here, no matter what type of quiz it is open notes. So you'll be able to use your notes on that. All right, so today's lesson is definitely a review lesson from Algebra 1, but definitely a big deal kind of lesson. Got to be able to solve equations because they're embedded within a lot of our problems that we do kind of throughout the year. Anyways, what we want to do on example 1 is, well, two things. We want to solve the equations we're given, but also kind of name the property that we're using as we go throughout solving. So we don't have to write all these big long terms. We will just abbreviate. So instead of like saying the addition property of equality, we'll just call that APE, and so on. The one under that, SPE, right? So just to save a little time there. So here is how we kind of want to do that. So on number 1, it says y plus 12 is equal to 8. We know the inverse of plus 12 is minus 12. So that's what we want to do to both sides to kind of isolate that variable. All right, so that's going to leave me with y, plus 0 on the left side, or just y by itself equals whatever 8 minus 12 is, so negative 4. So as far as showing the minus 12 on both sides, really, we shouldn't be doing that by, we shouldn't have to do that. So if you want to skip that part, that's fine. I do want you to write what we did, though, since we subtracted from both sides. That would be the subtraction property of equality. So we'll call that SPE for short. Are there? Okay. So, yeah. All right. So let's, multiple SPEs. So let's make that first one a little longer. Let's call it the SUBT property of equality. All right, so thank you for pointing that out. Okay, any questions before we move on? All right, so number 2 is a two-step equation, so we will list multiple properties here. The first thing we would probably do there is add 9 to both sides. Since all those terms are divisible by 3, you could divide everything by 3, but usually we'd add 9 first, so we'll go ahead and do that. When we add 9 to both sides, we're left with 3p equals 21. So since we added there, that would be the addition property of equality. There are no other APEs, so we'll just call that APE. And then we're going to divide both sides by the coefficient, which would leave me with 1p, or p equals 21 over 3, which is 7. P equals 7. So there we use the division property of equality, and there's no other DPE, so we'll just call it DPE. I kind of forgot to look exactly at MathXL, so how that'll look, I'm not sure if you have to name the steps or not on MathXL. We'll figure it out kind of when you guys start working. All right, so you guys, with the naming of the steps, 2 minutes may not be enough time to finish both of these, but go ahead and give it your best. Just at least get 2 minutes ahead of me. You're working 3 and 4 if you have time. And I probably will just kind of call on you guys to make sure that we're all kind of on the same page. Answer only will be fine. I'll kind of go through the steps and whatnot. So just answer only if you get called on, and if you like, if I call on you for 4 and you didn't get there, just let me know. All right. So let's see. Tori, what'd you get on number 3? What's Q equal to? Q equals 4 is correct. Very good. So I would just say at the beginning, there are a couple different things you could do. You could distribute. You could also treat that 3 like a coefficient. So, you know, if 3 goes into 6, it might be the easiest way to start. It might have been to divide both sides by 3, use that division property of equality, and that would leave us with Q minus 2 equals 2, right? And then so that would be the division property first. And then add 2 to both sides. Did you have to do that? No. Some people probably distributed the 3 first and got the same answer, right? So neither one is any more correct than the other, right? Just good to know multiple ways to work through an equation. Yes. That is not a property of equality. So that's just when you, so that would just be like simplifying a side. So yeah, we're just using the distributive property, but it's only like a property of equality if I'm doing it to both sides. Okay, so good question there. Anything else before we move on? All right, and then number 4, May, were you able to get through that one? Okay, that's all right. Let me try one more, and then I'll maybe take a volunteer. Nate, did you get number 4? Okay, anybody? Anybody got number 4? Yes. 1.2 is correct. Very good. So how can we work through that one? I would say probably your best bet to start with, just as far as being efficient, would be what I would do is get rid of that denominator first. That's what I would do. So I would use the multiplication property of equality here and multiply both sides by 6. All right. When I do, I get, you know, 6t over 6, which is t on the left side. And then on the other side, I have negative 24t plus 30. Now what I'm dealing with is a lot, you know, a lot easier to deal with, okay? So, you know, from there, we'd probably just want to move our, you know, t's to the same side. Move that timer so I can write that out. So that was the multiplication property. So then I would add 24t to both sides. That's going to give me 25t equals 30. And then, of course, divide both sides. I always want to skip that step. Then divide both sides by 25 to get t equals 30 over 25, which is equivalent to, you know, you could say 6 over 5 or 1.2. Either way would be fine. We'll go with 1.2 since that's what our volunteer had. Any questions on that one? Yeah. So if we're dealing with you know, fractions and stuff and trying to solve an equation, I think the best thing to do for me is get rid of those denominators if and when we can. Okay. Any questions? All right, moving on. All right, so let's do one of these word problems and see if you guys can kind of catch on there. Says the length of a rectangle is 12 centimeters more than the width. The perimeter is 44 centimeters. Find the length and find the width. All right, so what we kind of need to know here is a formula for the perimeter. So you could say perimeter is equal to 2L plus 2W, or you could use 2 times the quantity, L plus W. Either one, okay? Once we are kind of working with that, then we can substitute in some values, all right? So one value we're going to have to substitute in is this expression for length. So it says length is 12 more than the width, so we'd say L equals width plus 12. And then perimeter is 44. That's pretty straightforward. That would just be P equals 44. Okay, and then we just pick, we can either use this as our outline to set up our equation, or P equals this. It doesn't really matter, whatever you want to do there, okay? I think we're more used to seeing the first one, so I'll use that one, but you could use the other one, okay? So when I substitute in what my equation is going to say, instead of P equals is 44 equals. And then instead of 2L, I'd have 2W plus 12. And then 2W is just 2W. All right, so then we just want to try to solve for W. So obviously we need to simplify that right side by distributing first. That gives me 44 equals 2W plus 24 plus 2W. Now combine like terms. So at that point, we have 44 equals 4W plus 24. And now we just have a pretty simple two-step equation. I'm out of room, so I'm going to kind of continue my work over there. Minus 24 to both sides gives me 20 is equal to 4W. Divided by 4 on both sides gives me 5 equals W. So we know the width is 5 centimeters, and now we can use that to find the length, okay? So we remember L is equal to W plus 12. So that would just be 5 plus 12, or 17. Okay, so in other words, that is a 17 centimeter by 5 centimeter rectangle. That's what we just figured out. We probably really should put a label on that, but I'm just going to take a shortcut. Box those in. All right, let's see. If we have time at the end, we'll come back to this, try it. For now, let's just skip it and get to these literal equations. So sometimes these can be a little bit tough, especially if you don't have very good fundamentals as far as like solving your equations, all right? Because these are more abstract, less concrete than just solving for solving an equation that just has one variable in it. All right, these have multiple variables. Okay, so 3a wants us to just solve the equation ax minus b over 2 equals x plus 2b. And they basically want us to solve it. So this is a roundabout way of saying, so it says, what is x in terms of a and b? This is another way of just saying solve for x. Okay, that's all they're wanting us to do. Okay, so looking at our equation, our original equation, obviously we have kind of multiple x's there, right? So lots of things you could do on these, but we want to try to get those kind of x's to the same side. So, like I said, kind of to start with, I like to get rid of any denominators if I can, right? So what could I do to both sides to get rid of any denominator that we have? Yes? Multiply both sides by 2. Okay, so using that multiplication property, that would give me ax minus b equals 2x plus 4b. So again, what we do there, you don't have to label them here. I'm just gonna for the video, but there we use the multiplication property of equality. All right, now let's try to get our b's to one side and then our x's kind of to the other. So let's go ahead and I'm gonna kind of do two things at once here. So I'm gonna subtract 2x from both sides, and I'm gonna add b to both sides. So that would leave me with ax minus 2x equals 4b minus 1b, which would be what? 3b. So on the right side, it's a lot cleaner, right? We can't, the reason we have to write ax minus 2x as two terms is because like a and 2 aren't like terms, right? Yes? Did I do it wrong? Yeah, we should have added. Yeah, thank you. Yeah. So the question was, why did we subtract b if it's negative? Should have added b there. So thank you for catching that. So change that to 5b. I owe you a piece of gum for that one. If you catch a mistake, you get some. Gum's all I got right now. We're early in the year, so keep those corrections coming. All right, now, does anybody know how to deal with getting the x by itself from here? Anybody remember how to do this one? So what we do here is we use the distributive property. All right, so basically we factor out an x from the left side. So this last one was addition property, and really subtraction property. All right, but now we're going to use the distributive property. So we're going to factor out an x, and we're going to rewrite the left side as x times the quantity a minus 2. So that's distributive property. And then we can divide both sides by a minus 2, right? We can treat that like almost like a coefficient of x, okay? So when we do that, that's going to give me x equal to 5b over the quantity a minus 2. Another way you could write that is x equals 5b over a minus 5b over 2. Okay, this is just maybe a simpler way to write that. All right. So let's go ahead and let's do the next one together, and then I'll have you guys try number 7. So we're solving for m here. Okay, this one's a lot simpler. I'd probably subtract 2m from both sides. That would give me 1m. Let's go ahead and add n to both sides as well. Just save us a little bit of room here. So that's going to give me 2n on the other side. And that's all she wrote. We're already solved for m there. All right, so let's have you all try this next one. Let me give you a few more seconds than what I had planned to give you. Whoop. Sometimes that timer just starts running. There you go. All right, so trying to solve for you here. Trying to solve for you. So instead of calling on you guys, I'm just going to start to work it out on the board. For anybody who's stuck, you can just work along with me. If not, just keep going and check when you as you finish. Oh, okay. I'm like, that's not looking like my notes. Got two different variables there. So that's going to give me W minus 6V. All right, so we get we get U equals W minus 6V over 7. So just kind of talk you through this. First, I distributed. The next step is I kind of got all my U's to one side and everything else to the other side. So to get from here to here, I used the addition properties and subtraction properties of equality. I did addition and subtraction to both sides here. And then I just divided both sides by 7. All right. So yeah, like I said, these are probably the toughest ones on your homework, these literal equations, but you know, we can look at more if we need to. Okay. Any questions before we move on? All right. So last one, these no solutions or infinitely many solutions. So basically, remember with equations, sometimes if you're solving for a variable, you can have you know, both sides kind of get rid of the variables, right? And that's always going to be an infinitely many solution or a no solution. So let's look at one. Have you try one, and we'll see if we have any time to start that assignment. All right, looking at number 1. Go ahead and probably simplify both sides first. Let me make sure I'm seeing that right. Yeah. So I'm going to simplify the left side to be 5x minus 5, and then the other side to be 5x minus 5. Really, at this point, you can tell probably what it is. If you have the exact same expression on both sides, that's going to be, which one would it be, IMS or no solution? Anybody know? That's going to be always. That's the language they use here. My preference is infinitely many solutions, but yeah, this would be always true. Now, if you have to show another line of work, right? What we want to do there is say, okay, we're going to subtract 5x from both sides, so that's going to leave me with -5 equals -5, which is always true, right? So. So to answer the question in their form, always, but usually we say that's infinitely many solutions, IMS for sure. All right, you try the next one, and then we'll take a little break before we get started on the homework. Yeah, just sign out. so I went ahead and showed the work up there, and it's answered. So just look that over, make sure you're all good to go. Anybody have any questions? All right, so let me go ahead and end that recording. Why don't you guys take like a 2-minute quick break, and then I'll post the assignment. We'll maybe be able to do one or two before we go.